So is my screen up?
Yes, it is.
Perfect. Thank you.
Thank you. So welcome to the LunaRecycle Challenge Webinar. And I'm going to, in this very brief period of time, I'm going to give a kind of a little overview of both product lifecycle management, which is implicit here, and the digital twin, and looking at what we can do with this digital twin today. And I am absolutely in agreement with everything John said about the fact that this is an explosive area. When John and I started this, digital twins were probably related to aerospace and automotive, and subsequently I'm seeing digital twins in pretty much every industry and aspect of life that you can imagine. So I think that you're going to see and continue to see an exponential increase in the kinds of capabilities, and I'll spend a few minutes telling you why. But first, I wanted to talk a little bit about the overarching area here, because it has application to what we're talking about. And this is the digital twin product lifecycle. And in fact, the digital twin what didn't even have a name to begin with. It was the underlying premise of product lifecycle management. But what this is showing is we now have a product-centric perspective of our objects and things and products, where we used to have a functional perspective. And John just alluded to that in terms of having silos of information. What we really want to do is to populate and consume a central source around a product lifecycle. And I divide the product lifecycle into kind of these simple areas. We create the product, we build the product, we operate and sustain the product, and then we dispose and recycle the product. With respect to what we're talking about on the moon, while I certainly believe in being a good steward of the environment, our issue up there is not going to be that we can't find places to put our disposed of product. The issue of it is that pretty much everything currently that we have up there, we have to bring up there, which is very expensive. So if you look at this sort of product lifecycle perspective, we want to recycle as much as we can, because it's a continuous loop. We go from dispose, recycle to creating products. And so the more that we can recycle and put to reuse in the moon environment is going to basically dramatically decrease the amount of cost of having to ship up there. UPS charges a lot to ship to the moon, and we want to make sure that we can recycle as much as we possibly can in order to be as efficient and effective as possible. And if you're interested in more of that, you can see my first book, which I have listed down there below. John is absolutely right. The definitional aspect of digital twins, and in point of fact, the last time I looked, there were like 500,000 definitions. Some were duplicated, but there's a huge definitional issue with digital twins. And I always liken it to the parable of the blind man and the elephant. Depending on what part of the elephant they were touching, whether it was the tusks or the hide or the tail, they described it differently. And I think that with the idea that a picture is worth 1,000 words, the digital twin model is really what we want to be able to use in order to understand what the digital twin is. And in essence, it has three major components. Over on the left side, you see the physical objects in physical space, and we've had those in time immemorial. The issue has been that we wanted to think about something new. It had to take physical form immediately. We had to do a drawing, blueprint, build a prototype of it. And so we were very limited when we came up with new ideas. It was very expensive to translate those into actual physical products. On the right side, we have what I call virtual space, which is digital space, and it contains not only the digital objects that we have corresponding over in the physical world, but it also has the environment which those objects operate in. Initially, we just started off with the object itself, but now, in fact, we're using the term metaverse. And in fact, John and I participated in a book that just came out called Digital Twin Simulation of the Metaverse, in terms of talking about having metaverses that will allow us to have not only the geometry of these things, but also how they're going to behave. The third aspect is connecting between them, and it's bidirectional. We have data that comes from the physical world because, quite frankly, if we don't have what's happening in reality, the data of the physical world, we can't have a realistic digital twin that will replicate and predict what the future holds for us. And then what we want to do is we want to use information and data in order to be able to move that work that we're going to do over in this virtual space into the physical world. And why do we want to do that? We want to do that because in the 20th century and before, all our work activity, as I just said, occurred pretty much in physical space. As soon as we had an idea, it had to take physical form for us to share with other people. We want to move that work activity in the 21st century, which I really think we ought to call the third millennium, because we can substitute information that we generate over on the right-hand side for wasted physical resources in doing goal-oriented tasks that are over on the left-hand side. We actually have to expend physical resources to do physical things in our real world, but to the extent that we can do all our planning and checking out as to whether these things, the capability, and as John said, the testing in the virtual space, we can basically save tons of time, energy, and material, and especially elapsed time, which is what the clock runs on us, that is our most precious and valuable resource. We can never recover, as the clock ticks forward, we can never recover the past. So this three elements of the digital twin model is really what we're focused on. And it takes precedence over anybody's definition, including my own and John's, as to what a digital twin is. So I like referencing the model as opposed to word definitions, because I think word definitions invoke what you already know, but if you don't understand what it is, you need models that look like this. I want to briefly run you through the digital twin types. And as you can see, it basically ties back to the product life cycle that I talked about initially. The first thing we have is a digital twin prototype. So this is basically the idea that says as soon as we have an idea and we're going to actually manufacture it, we have what I call the prototypical digital twin. And what this means is the digital twin exists before there's a physical object that is going to exist. And so even though you're basically doing what I would call a digital twin prototype, the whole idea is it has to have the ability of being realized in the physical world. If it isn't, it's just pretty pictures or an animation, but your whole purpose here is going to be creating something that actually could be made when we basically follow all the plans. So these are all the products that can be made. And this is not only the drawing and engineering capabilities and things like that. How do we actually make it? What are the means of production? And we have to have those two things, what we're going to make and how we're going to make it, in order to be able to have a digital twin prototype. When we start to make things, and I'm talking about complex systems, not simple things, we want to have, as we make this, a digital twin instance. And this digital twin instance gets connected to its physical counterpart and exists throughout the entire life of that product, from the time it's built and rolls off the assembly line till it's disposed of. And in point of fact, the digital twin has an advantage because products wear out. The digital twin instance can continue on in perpetuity. So instead of just losing all the data we have with respect to our physical object, we basically will be able to have that digital twin in existence for as long as we need it. And so these are the individual products that are made. Finally, and this is where it really gets interesting, is this is the digital twin aggregate, which if we basically look at all how they perform, the population of them, we will be able to do prediction of what is going to occur, because when we see certain sensor readings, we are going to based on our digital twin aggregate, know, or at least have probabilities of what's going to happen. So these are all the products that have been made. So in terms of scope and scale, we're basically seeing all kinds of things: automotives, mining, and now mining on the moon, power generation systems, airplanes, ships, oil platforms, digital twins of smart cities, of people from a biology standpoint, not how they behave. Pharmaceuticals are developed this way. And then, as you heard, a digital twin of the Earth, which we really have a long way to go on that because it's the most complex system I think we have in the universe. But we're also going to have digital twins of intangible things. So because of humans, if we can visualize in our own minds, we can have a digital twin of it, even if it doesn't take physical geometry. It's going to have a presence in terms of the use of physical resources in the world. And so logistics systems, the process industry per se, I've seen it on entire economic systems, manufacturing processes, and then supply chain, or what I call the supply net, which is the virtual counterpart of these products. And so not only I had the idea that we could have intangible products to begin with. This was such a new concept that we only talked about tangible products, but clearly we can have intangible things like shown here in terms of our digital twins.